So continuing with our gas law conversion practice, question number 9 has a container with two gases. We have helium, we have argon, and it is 30% helium by volume, and it wants to know the partial pressure of helium and argon if the total pressure is 4 atmospheres. So of course we know from our partial pressure equation, the pressure total is going to be the pressure of helium plus the pressure of argon. And we also know that using our mole fraction equation, the mole fraction of helium is going to be equal to the number of moles of helium over the total moles. It can also be equal to the pressure of helium over the pressure total. So that's of course what we're going to be looking at in this question. We are going to see that we are asked to find the partial pressure of helium, and we know the mole fraction because we're given that it's 30%. So if the mole fraction is 30%, and we know that the total pressure is 4 atmospheres, we can solve for the pressure of helium. It's in the denominator, so we're going to multiply both sides, and we're going to find out that 1.2 atmospheres is equal to the partial pressure of helium. The last problem that I have on the review sheet is fairly complicated, but I wanted you to see how you can put it all together to use gas laws in kind of a common day occurrence. In a combustion engine, we have combustion going on of a gas, and so complete combustion of a 1.05 grams of ethylene glycol, which has a molecular formula of C2H5O2, produces a mixture of water and carbon dioxide, and those are all gases. And it says, what is the pressure of this gas mixture? So what is the pressure total when it is contained in 3 liters? We know that's the volume, and it's at a temperature of 127 degrees C. And of course we want to convert our temperature to Kelvin, so that is also 400 degrees Kelvin. So we notice a couple things. We notice that we have a reaction where we start with something and we end up with water and CO2, and we know that that's a combustion reaction. So the first thing we want to do is write a balanced chemical equation. So we know that if we have ethylene glycol, then we know if we have complete combustion, we're going to be adding oxygen to it, and we get water and CO2. Of course, that's probably not balanced. So once we go through, we balance all our things. We figure out we have 4 of those, and we have 10 of those, and 8 of those, and we have to balance our oxygens. We get 9 oxygens. So we write our combustion equation, and we can look at all of the ethylene glycol and oxygen are used up, and so they're all gases. So that tells us a couple things. It tells us that we can use our stoichiometric coefficients to help us predict the things. We can also use Gay-Lussac's law that says if all of the substances are gases, we can assume that they create 22.4 liters per mole. So that helps us determine volume as well. So we want to find the pressure. That's what we're looking for, total pressure. We have volume, we have temperature, and we can use our balanced chemical equation to help us figure out the number of moles. We're given that we have a mass of 1.05 grams of ethylene glycol, so we want to convert that to moles right away. Anytime we have grams, we want to convert it to moles. And so we know that 2 carbons plus 5 hydrogens plus 5 oxygens gives us a molecular mass of 61 grams per mole. And that tells us that we have 0.017 moles of ethylene glycol that are going to participate in this reaction. So if we have 0.17 moles of that would substitute in there, and so we would look at the ratio, right here, the ratio of our stoichiometric coefficients, and so we would find that 0.17 compared to oxygen, okay, we're going to use our stoichiometric coefficients in here, and we know that for every 4 moles of ethylene glycol, we need to have 9 moles of oxygen. And so in order to completely combust 0.017 moles of ethylene glycol, we would multiply it by that fraction, and we would find that we would need 0.038 moles of oxygen. We would do the same thing, 0.017 moles of ethylene glycol, to determine how much water we would need. So again, we have a 4 on the bottom, and a 4 compared to our water would give us a mole fraction of 0.0425 for water. And the same if we did moles of ethylene glycol to carbon dioxide, would tell us that that would create 0.034 moles of carbon dioxide. So after we've done all that, how does that help us determine our pressure? Well, we know that we're going to combust all of those things, and so we can add them together to figure out the total number of moles in the reaction. And so our reaction is, our products are going to be ending up being water and carbon dioxide. So we want to add the number of moles in that we use in that reaction. So the number of moles was 0.0425 and 0.034 of carbon dioxide. So the total number of moles of product, if we add those together, is 0.0765 moles that were produced by our complete combustion of ethylene glycol. So that would be the moles that we use. I'm going to check. So we're going to use our Pivnert. And so our moles are 0.0765 moles times 0.0821 liter atmospheres per mole Kelvin. And our temperature is 400 degrees Kelvin. We are solving for pressure, and so we're going to divide by volume. We knew that we had 3 liters, and so putting all this together, the pressure in there is going to be 8.37 atmospheres. I hope that this has kind of helped clear up any questions you had about the gas laws. Be sure you understand your formulas, and I will be giving you most of the formulas on the test. Be sure you understand how to convert all of your pressure units from torr to psi to millimeters of mercury to atmospheres, and how they all relate. Of course, if you have any questions, please wiki me, email me, call me. I'm happy to answer any questions that you have. Happy studying!